The metallic clang echoed through the Normandy countryside as Oberleutnant Hans Müller's Panzer IV shuddered to a halt. Smoke poured from its engine compartment, while 3 American Sherman tanks circled like predators around wounded prey. The acrid smell of burning oil mixed with the metallic taste of fear in Müller's mouth as he fumbled for his pistol. "Impossible," he whispered, his voice barely audible over the crackling flames consuming his tank's rear deck. These were supposed to be the inferior tanks. The Americans called them Ronsons themselves, lighting up at first hit. But here he was, one of Germany's elite Panzerwaffe officers, the hunter becoming the hunted, watching his supposedly superior German engineering burn, while 3 paper-thin Shermans prepared for the killing blow. Through his periscope, he could see more dust clouds on the horizon, more American tanks approaching, an endless stream of olive-drab steel that defied everything he'd been taught about armored warfare. The irony was bitter. Müller remembered laughing just 18 months earlier when Hauptmann Weber had shown him captured American technical manuals for the M4 Sherman. "Look at this construction," Weber had chuckled, pointing to the welded hull diagrams. "Riveted plates, soft steel armor, a high profile that screams, 'Shoot me first.' The Americans are building tanks like they build automobiles, cheap, fast, and disposable." The entire officers' mess had erupted in laughter that night. These Americans, they reasoned, were trying to fight a European war with Detroit assembly line mentality. It was a fatal mistake that would cost them dearly when they finally dared to face the Wehrmacht's steel fist in honest combat. Now, as Müller watched his crew bail out of their burning Panzer, while American tank crews methodically reloaded their guns, he understood the terrible truth. The Americans hadn't made a mistake at all. They had made a calculated decision that was about to reshape the entire nature of armored warfare. The laughter in that officer's mess would prove to be the most expensive joke in military history. Just 18 months earlier, in the sterile conference rooms of the Wehrmacht's Panzerwaffe headquarters in Berlin, German tank commanders had shared hearty laughs over intelligence reports about America's new medium tank. The M4 Sherman, they called it, a crude mass-produced box on tracks that any respectable Panzer crew could dispatch with ease. General Major Friedrich von Mellenthin had personally dismissed them as mobile coffins, while Oberst Hermann Balck famously quipped that 10 Shermans are worth 1 Panzer IV and 20 are worth 1 Tiger. The room had erupted in laughter that echoed through the marble halls of German high command. These Americans, they reasoned, had chosen quantity over quality, the desperate gambit of a nation that understood neither the art of war nor the science of armored combat. General Oberst Heinz Guderian himself had reviewed the intelligence reports with amused disdain. The man who had pioneered blitzkrieg warfare, who had led German panzers from Poland to the gates of Moscow, could barely contain his contempt for American tank design philosophy. "They are trying to win a war of movement with trucks," he had written to Field Marshal von Manstein. "When our Tigers and Panthers meet these industrial products in battle, the Americans will learn the difference between mass production and military excellence." The confidence wasn't entirely misplaced. German tank technology in 1943 represented the pinnacle of armored vehicle development. The Panzer IV AOSFH, backbone of German armored divisions, mounted a long-barreled 75mm gun capable of penetrating Sherman armor at ranges exceeding 2,000 meters. The fearsome Tiger bomber, with its 80mm gun adapted from anti-aircraft use, could destroy any Allied tank at virtually any combat range while remaining effectively invulnerable to return fire. Most terrifying of all was the new Panther, combining the Tiger's firepower with superior mobility and sloped armor that could defeat even the most powerful Allied anti-tank weapons. These weren't just superior machines. They were manifestations of German engineering philosophy that prioritized perfection over practicality. Each Tiger tank required 300,000 man-hours to complete, employing precision manufacturing techniques that produced vehicles of breathtaking complexity and capability. German tank crews trained for months on their specific vehicles, learning every mechanical system, every maintenance procedure, every tactical capability. The result was an elite force of mechanized warriors operating the most advanced armored vehicles in human history. How spectacularly wrong they were. By May 1945, those same German officers who had mocked the Sherman would witness something that defied every principle of armored warfare they thought they understood. In just 11 months of combat, from D-Day to victory in Europe, American factories had not just built tanks, they had unleashed an industrial tsunami that would drown the Wehrmacht in steel. The numbers alone told a story that German intelligence had completely failed to grasp. 49,234 Sherman tanks rolling off American production lines, shipped across an ocean and delivered to the gates of Berlin itself. But the numbers were only part of a larger transformation that would revolutionize modern warfare. The Sherman program represented nothing less than the industrialization of military victory, the application of American mass production techniques to the ancient art of armored combat. While German craftsmen were hand-fitting Tiger tank components in specialized factories, American workers were stamping out Sherman parts on automotive assembly lines that never stopped running. The story begins in 1940, when America was still watching Europe's war from across the Atlantic, officially neutral but increasingly concerned about Nazi expansion. While German panzers carved through French countryside and British formations retreated across Belgian plains, American engineers at the Detroit Tank Arsenal were sketching designs for what would become the most controversial tank in military history. The project began not with military specifications, but with industrial ones. How to build an effective tank using existing American manufacturing capabilities and automotive industry expertise. Lieutenant General Leslie McNair, the architect of American armored doctrine and head of Army Ground Forces, had made a calculated decision that would prove prophetic. Instead of chasing the Germans in an arms race toward heavier, more complex tanks, America would overwhelm them with numbers, reliability, and industrial capacity. "We don't need to build a better mousetrap," McNair had told skeptical officers during a heated Pentagon meeting in early 1942. "We need to build 10,000 mousetraps and ship them anywhere in the world within 6 months. The Germans can build perfect tanks for European warfare. We need to build adequate tanks for global warfare." This philosophy horrified American tank specialists who had studied German armored success in Poland and France. Brigadier General Alvin Gillam, chief of the armored force, argued passionately for competing with German technology. "If we send our boys into battle with inferior equipment, we're sending them to die," Gillam had protested. "German tank crews are the best trained in the world, operating the most advanced vehicles ever built. We can't expect American courage to overcome German engineering." McNair's response would echo through American military doctrine for the next 8 decades. "We're not trying to build tanks that can beat German tanks one-on-one. We're trying to build an army that can beat the German army. Those are entirely different problems requiring entirely different solutions." The M4 Sherman that emerged from this strategic thinking was deliberately designed as a compromise between capability and manufacturability. Its 75mm gun was adequate for 1942 battlefield conditions. Its armor provided reasonable protection against contemporary anti-tank weapons. Its mechanical systems prioritized reliability over performance. Most importantly, its construction methods allowed automotive manufacturers to produce complete tanks using existing industrial infrastructure. The German High Command, drunk on early victories and convinced of their technological superiority, completely misread this strategy. In captured German documents from late 1943, General Oberst Heinz Guderian, the father of German tank warfare, wrote dismissively about American armored capabilities. "The Americans appear to be mass-producing a mediocre tank in the misguided belief that quantity can substitute for quality. Our Panzer crews will make short work of these industrial products when they finally dare to face us in honest battle." The Sherman tank represents everything that is wrong with American military thinking: industrial efficiency applied to problems that require warrior excellence. This arrogance was rooted in genuine technological advantages that seemed to validate German confidence. The Panzer IV OSF F2, introduced in 1942, could penetrate Sherman armor at ranges exceeding 1,500 meters, while the Sherman's 75mm gun struggled to damage German tanks beyond 500 meters. The fearsome Tiger I, weighing 57 tons and mounting an 88mm gun originally designed for anti-aircraft use, seemed practically invulnerable to anything the Allies could field. German tank crews had every reason for confidence. In head-to-head duels, German tanks consistently outperformed their opponents by margins that seemed decisive. Major Otto Carius, one of Germany's most successful tank commanders, captured this confidence in his wartime diary. The Americans are sending their boys to fight us in mobile coffins. We destroyed 3 of their Shermans yesterday at ranges where they couldn't even see us clearly. It's almost unsporting. These machines might work against inferior opponents, but against German armor they are simply targets. I almost feel sorry for the crews inside them. But war, as American planners understood, is not fought in duels between individual vehicles. It's fought in campaigns across continents over months and years of sustained combat, involving millions of soldiers and thousands of vehicles. And in this broader context, the Sherman's apparent weaknesses would transform into devastating strengths that German military thinking simply couldn't comprehend. The first hint of what was coming appeared in North Africa during 1942 and 1943, where British and American forces equipped with early Shermans began pushing back Rommel's Afrika Korps. German tank commanders noted with growing concern that while individual Shermans were no match for their Panzers in direct combat, they seemed to appear everywhere at once. Hauptmann Wilhelm Crisoli, commanding a Panzer company in Tunisia, wrote increasingly worried entries in his diary as the campaign progressed. "We destroy 3 American tanks in the morning and 5 more appear by afternoon. We retreat to new defensive positions and they are already there waiting for us. We knock out their lead vehicles and more keep coming. Where are they getting so many tanks? Our intelligence reports suggest American production is limited, but the evidence of our eyes tells a different story." The answer lay 4,000 miles away, in factories that had been automobile plants just 2 years earlier. The Detroit Tank Arsenal, a massive facility built specifically for tank production, was already producing 400 Shermans per month by early 1943, with production increasing monthly as workers gained experience and assembly line procedures were refined. Chrysler's tank plant in Detroit added another 300 vehicles monthly, while Ford's Willow Run facility, better known for producing B-24 bombers at unprecedented rates, had been partially retooled to manufacture Sherman components at a pace that staggered even American production experts. The scale of American tank production defied German comprehension because it operated on principles entirely foreign to European military thinking. Where German factories employed skilled craftsmen working with precision tools to create individually perfect vehicles, American plants used semi-skilled workers operating standardized machinery to produce interchangeable components. A Sherman tank transmission built in Detroit was identical to one manufactured in Chicago or Los Angeles, allowing for unprecedented logistical flexibility and maintenance efficiency. By June 1943, American factories were completing 1 Sherman tank every 47 minutes, around the clock, 7 days a week. The rhythm never stopped. As one tank rolled off the final assembly station, another hull was already moving down the production line. The Pullman Standard Car Manufacturing Company had converted its railroad car facilities to tank production, adding another 200 Shermans monthly to the growing flood of armor. Fisher Body Division, famous for automotive work, was producing tank hulls and turrets. Lima Locomotive Works, Pacific Car and Foundry, Federal Machine, and Welder Company, industrial concerns that had never built military vehicles, were suddenly outproducing the entire German tank industry combined. The human stories behind these statistics were equally remarkable. Rosie the Riveter wasn't just building aircraft, she was welding Sherman tank hulls in factories that operated around the clock. Martha Johnson, a former secretary from Detroit, found herself operating a precision boring machine that cut cannon barrels for Sherman main guns. "I'd never seen a tank before the war," she recalled decades later. "Now I was building the guns that would go inside them. We knew our boys were depending on us, and we weren't going to let them down. Every tank that went out those doors carried a piece of our hearts with it." The numbers were staggering, even by American industrial standards. In 1943 alone, American factories completed 17,565 Sherman tanks, more than Germany would produce of all tank types throughout the entire war. But raw production was only half the story. The other half was logistics, the unglamorous but decisive art of getting those tanks where they were needed, when they were needed, with fuel, ammunition, spare parts, and trained crews ready to operate them effectively. German planners had consistently and catastrophically underestimated American logistical capabilities. Wehrmacht intelligence reports from 1943 suggested that even if Americans could produce large numbers of tanks, They lacked the shipping capacity to transport them across the Atlantic, while simultaneously supporting Britain with lend-lease supplies and maintaining their own growing forces in the Pacific theater. This assessment, like so many German intelligence failures, proved spectacularly wrong. The Liberty ship program, running parallel to tank production, was creating cargo vessels faster than German U-boats could sink them. By 1944, American shipyards were launching 3 Liberty ships every 2 days, each vessel capable of carrying 50 Sherman tanks, plus their complete support equipment, spare parts, ammunition, and fuel. The Kaiser shipyards in California had revolutionized ship construction by applying automotive assembly line techniques to naval production, completing entire cargo ships in 37 days from laying the keel to final sea trials. The logistics network supporting Sherman deployment would have impressed ancient Roman engineers. Specialized rail cars carried tanks from factories to ports. Dedicated loading equipment could transfer a Sherman from rail car to ship in under 30 minutes. Purpose-built transport vessels included maintenance facilities, allowing tanks to be serviced during ocean crossings. The entire system was designed for speed, efficiency, and massive scale, exactly the capabilities needed to support global warfare. Meanwhile, in occupied France, German commanders were beginning to realize they faced an unprecedented challenge that their military education had never prepared them to understand. Oberst Hans von Luck, whose 21st Panzer Division would face the D-Day landings, later recalled the growing sense of unease that permeated German planning sessions throughout 1943 and early 1944. We knew the invasion was coming. We had studied the coastal maps, prepared the beach defenses, positioned our mobile reserves. What we had not prepared for was the scale of American material superiority. Our intelligence estimates suggested they might land with 200-300 tanks in the first wave. The reality was closer to 2,000, with more arriving every day. Field Marshal Erwin Rommel, tasked with defending Hitler's Atlantic Wall, understood the implications better than most German commanders. In a letter to his wife, Lucy, written in March 1944, Rommel revealed his growing concern. The enemy's material superiority is so overwhelming that we cannot hope to compete vehicle for vehicle or gun for gun. Our only chance is to destroy them on the beaches before they can establish themselves ashore. Once they land in force, their industrial capacity will ensure our defeat through simple mathematics. D-Day itself provided the first real test of Sherman mass production philosophy versus German armored quality doctrine. The numbers were stark and revealing. German forces in Normandy could field approximately 1,350 tanks of all types, including 102 of the feared Panthers, 40 Tiger tanks, and the remainder being older Panzer IVs, along with a collection of captured French vehicles pressed into German service. Against this formidable but limited force, the Allies landed with over 3,000 tanks in the first week alone, with hundreds more arriving daily as Liberty ships unloaded their cargo on the Norman beaches. But even these impressive numbers don't tell the complete story of America's industrial triumph. German tanks, however individually superior, operated under crippling logistical constraints that grew worse with each passing month. Fuel was increasingly scarce as Allied bombing disrupted German refineries and transportation networks. Spare parts were nearly impossible to obtain as factories prioritized new production over maintenance support. Replacement vehicles were essentially non-existent. When a Panzer was knocked out, it often meant permanent loss of that unit's combat capability. Sherman crews, by contrast, operated within a logistical system that seemed almost magical in its abundance. Damaged tanks were repaired overnight by specialized recovery units equipped with spare parts, replacement components, and complete mechanical shops. Tanks deemed beyond field repair were simply replaced with new vehicles, often within hours of being lost. Crews knew that their survival didn't depend solely on their vehicle's protection. It depended on an entire industrial system dedicated to keeping them fighting. Technical Sergeant Joe Riley of the 2nd Armored Division captured this disparity perfectly in a letter home to his mother in Massachusetts. "Jerry's got better tanks, no doubt about it. Their Tigers can knock us out at twice the range we can hurt them, and their Panthers are faster and better armored than our Shermans. But here's the thing. Mom won't understand from reading the newspapers. It doesn't matter. We lost 3 tanks yesterday in a single engagement. And this morning we had 5 brand new ones waiting for us, with full fuel tanks and loaded ammunition racks. Jerry lost 1 Panzer in the same fight, and that's 1 less Panzer they'll ever have. We're fighting a war of addition and subtraction, and we're better at mathematics than they are. The psychological impact on German crews was immense and cumulative. Lieutenant Kurt Meyer, commanding a Panzer IV in the elite 12th SS Panzer Division, described the horror of facing seemingly endless Sherman formations in his post-war memoirs. "We would engage an American tank column and destroy the lead vehicles. Victory, we thought. Another successful ambush by superior German tactics and equipment. Then we would see the dust clouds on the horizon and our hearts would sink. More Shermans, always more. It was like fighting the ocean itself. You might stop 1 wave with heroic effort, but 10 more were already approaching, and behind them 10 more after that." This psychological warfare was compounded by the Shermans' unexpected resilience in combat. German tankers had expected American tanks to be fragile, easily destroyed machines that would break down under the stress of European combat conditions. Reality proved stubbornly different. While Shermans were indeed more vulnerable than German tanks in direct combat, they were engineered for battlefield survival, using principles German designers had never considered. Crew compartments were designed to protect tankers, even when the tank was penetrated and destroyed, meaning experienced Sherman crews lived to fight again in new tanks. German crews, protected by superior armor and fighting in technically superior vehicles, were paradoxically more likely to die with their tanks when finally overwhelmed. The mechanical reliability gap was equally decisive and grew more important as the war progressed. German tanks, marvels of over-engineering that represented the pinnacle of precision manufacturing, required extensive maintenance and frequent repairs that consumed enormous amounts of time, spare parts, and skilled labor. A Tiger tank needed 40 hours of maintenance for every 10 hours of operation, time that was increasingly unavailable as Allied forces maintained constant pressure. Panthers were notorious for transmission failures that often occurred before the vehicles reached combat, earning them a reputation for unreliability that undermined crew confidence. The complex interleaved road-wheel suspension system that gave German tanks their superior cross-country performance and smooth ride also created maintenance nightmares. Changing a single damaged road wheel required dismantling half the suspension system, a process that took trained mechanics 8 to 10 hours under ideal conditions. In combat zones, such repairs were often impossible, meaning tanks were abandoned for relatively minor damage. Shermans, by contrast, were designed using automotive engineering principles that prioritized mechanical simplicity over theoretical perfection. Ford Motor Company's decades of experience building reliable vehicles for civilian use translated directly into tanks that could operate for weeks with minimal maintenance. The vertical volute spring suspension system used commercially available truck components that could be replaced in field conditions using standard tools. The engine, based on proven aircraft radial designs, ran reliably on multiple fuel types and could be completely replaced by a trained crew in under 4 hours. Major General Maurice Rose, commanding the 3rd Armored Division during its drive across Western Europe, summarized the impact of this engineering philosophy in terms that any soldier could understand. The Germans built tanks like Swiss watches, precise, beautiful, and temperamental. Every component was perfectly machined, every system was theoretically optimal, and every repair required a specialist. We built ours like pickup trucks, reliable, serviceable, and available. Any mechanic who could fix a Ford could fix a Sherman. In a war of attrition, the pickup truck wins every time because it's still running when the Swiss watch has broken down. By late 1944, the cumulative effect of American tank production was becoming apparent across all fronts where German forces were engaged. The numbers were staggering. American factories had produced more Sherman tanks in 1944 alone than Germany had produced of all armored vehicles throughout the entire war. But production numbers were only part of a larger transformation that was reshaping the nature of armored warfare itself. In the Ardennes, during what Americans call the Battle of the Bulge and Germans called Operation Watch on the Rhine, German forces managed to achieve tactical surprise and significant initial success against American positions. For a brief moment in December 1944, it seemed possible that concentrated German armor might achieve a decisive breakthrough using traditional principles of armored warfare. German commanders dared to hope that superior equipment and elite crew training might overcome American material advantages. But within 72 hours, the fundamental reality of American industrial capacity reasserted itself. American armored reserves were arriving from across Western Europe, reserves that existed only because American factories could produce tanks faster than German forces could destroy them, even during their most successful offensive operations. The Battle of the Bulge became, in effect, a test of whether German tactical excellence could overcome American industrial supremacy. The answer was swift and decisive. Oberst Otto Skorzeny, the famous German commando leader who had rescued Mussolini and led special operations throughout the war, witnessed the American response to the Ardennes offensive firsthand while commanding a unit of English-speaking German soldiers tasked with spreading confusion behind American lines. In his post-war memoirs, published decades after the war, Skorzeny wrote with grudging admiration, "We achieved everything we had hoped for in the opening phase of the offensive. We broke through American lines, captured thousands of prisoners, seized important road junctions, and advanced 30 kilometers in the first day. Our Tiger and Panther tanks performed magnificently, destroying Sherman after Sherman in exactly the kind of combat we had trained for. But by the third day of fighting, it was clear we had accomplished nothing meaningful. New American tank units appeared as if materialized from thin air. Every Sherman we destroyed was replaced by 2 more. It was then that I knew with absolute certainty that the war was truly lost." The Eastern Front told the same story with even more dramatic numbers. Soviet forces, equipped with thousands of American-supplied Shermans through the Lend-Lease program, were pushing German armies back toward Berlin, using American industrial capacity to supplement their own massive tank production. These weren't even tanks fighting for America, they were American tanks fighting for Russia, demonstrating the global reach of American industrial power and the strategic vision that had prioritized Allied victory over narrow national interests. Stalin himself, certainly no friend to American capitalism and suspicious of Western motives, grudgingly admitted in private conversations with his marshals, "The Americans have proven something we did not fully understand. Mass production is itself a weapon of war, perhaps the most decisive weapon. They have turned their factories into arsenals and their workers into soldiers. We must learn from this, because wars of the future will be won in factories as much as on battlefields." German tank ace Michael Wittmann, credited with destroying 138 enemy tanks during his legendary career and holder of the Knight's Cross with oak leaves and swords, encountered this new reality personally during his final combat operations in Normandy. Despite his extraordinary skill, years of experience, and the technical superiority of his Tiger tank, Wittmann found himself increasingly isolated as American Sherman formations overwhelmed German positions through coordinated mass tactics that only vast numbers of vehicles could execute effectively. On August 8, 1944, near the village of Saint-Aignan-de-Cramesnil, Wittmann's Tiger was finally destroyed, not by superior technology or individual heroics, but by a combination of Sherman tanks, anti-tank guns, and artillery working together in the kind of coordinated assault that massive equipment availability made possible. The destruction of Germany's most famous tank ace symbolized the triumph of American industrial warfare over European military tradition. The production statistics by war's end were staggering and told a story of industrial transformation that extended far beyond simple vehicle manufacturing. American factories had completed 49,234 Sherman tanks, along with thousands of variants including tank destroyers, self-propelled artillery pieces, recovery vehicles, and specialized engineering equipment. This represented not just tanks, but an entire ecosystem of armored warfare capability, produced at scales no military force had ever achieved in human history. Germany, fighting desperately on multiple fronts while its industrial cities were systematically destroyed by Allied bombing, had managed to produce approximately 25,000 tanks of all types throughout the entire war, a remarkable achievement under the circumstances, but less than half of American Sherman production alone. The Soviet Union, despite massive industrial evacuation and the temporary loss of crucial manufacturing regions to German occupation, had produced over 100,000 tanks during the war years, many using American-supplied materials, machine tools, and technical expertise provided through Lend-Lease agreements. But perhaps the most telling statistic concerned operational availability rather than raw production numbers. Of the nearly 50,000 Shermans produced, over 40,000 remained operational at war's end, a testament not just to American manufacturing quality, but to the logistical support systems that kept them running. German tank production, hampered by material shortages, forced labor, and increasingly desperate conditions, suffered from decreasing quality throughout the war's final years. Many late-war German tanks were essentially hand-built by exhausted workers using substandard materials, creating maintenance nightmares that further reduced their battlefield effectiveness. The human cost of this industrial disparity was profound and often counterintuitive. American tank crews, fighting in supposedly inferior vehicles against technologically superior opponents, actually suffered lower casualty rates than their German counterparts during equivalent combat operations. The reason was simple but decisive. When an American tank was destroyed, replacement crews could expect new, well-maintained equipment within days, along with proper training, adequate support, and confidence in their logistical systems. German crews, fighting in superior tanks, faced increasingly longer odds because each loss was essentially irreplaceable, and surviving crews were forced to continue fighting in deteriorating equipment with inadequate support. Sergeant Bill Davidson of the 1st Armored Division captured this reality in a letter to his wife back in Ohio. "The newspaper boys keep writing about how our tanks aren't as good as the German ones, and maybe that's true if you're talking about one tank fighting another tank in some kind of medieval duel. But there's never just one Sherman on a battlefield. There's always 5 or 10 or 20, and tomorrow morning there will be more. The Germans can build better individual tanks, but they can't say the same thing about better armies. We're not just fighting tank against tank, we're fighting factory against factory, and Detroit beats Krupp every single time." Technical innovations also played a crucial role in the Sherman's ultimate success, demonstrating American adaptability and the advantages of large-scale production systems. While early models were indeed vulnerable to German anti-tank weapons, American engineers continuously improved the design based on combat feedback and battlefield experience. The Sherman Firefly, mounting a powerful British 17-pounder gun, could engage German armor on equal terms at combat ranges. The M4A3E8 Easy-8 featured improved armor protection and a more powerful 76mm gun with better penetration characteristics. Most importantly, these improvements were rapidly implemented across thousands of vehicles, rather than remaining limited to small numbers of prototype or experimental units. American production systems allowed for continuous refinement and upgrading, meaning that Sherman capabilities improved throughout the war, while German tank development remained constrained by limited manufacturing capacity and resource shortages. German technical improvements, while often superior in theoretical terms, couldn't be implemented at meaningful scale. The legendary Tiger II, with its 185mm frontal armor and long 88mm gun capable of destroying any Allied tank at extreme ranges, was arguably the most powerful tank of the entire war. Individual Tiger II tanks were nearly invulnerable to Allied anti-tank weapons and could dominate any battlefield they entered. But Germany produced only 489 Tiger II tanks during the entire war, compared to over 4,000 upgraded Sherman variants produced in the final year of combat alone. Superior engineering excellence means nothing in strategic terms if you can't produce enough vehicles to influence campaign outcomes. German tank development became increasingly focused on theoretical perfection rather than practical battlefield impact, a luxury that American planners understood they couldn't afford in global warfare. The war's end brought final vindication for American tank strategy and industrial philosophy. In the ruins of Berlin, American and Soviet Sherman tanks met the scattered remains of German defenders, equipped with whatever armored vehicles remained functional after months of fighting and bombing. The symbolism was inescapable and historically decisive. Tanks that German commanders had mocked as inferior were now patrolling the streets of the Nazi capital, while the vaunted Panzer divisions existed only as wrecked metal scattered across European battlefields. General Omar Bradley, reviewing American armored performance during post-war strategic assessments, observed with characteristic understatement, "We didn't win because we built better tanks than the Germans. We won because we built more tanks than they could destroy, shipped them farther than they could retreat, supplied them better than they could disrupt, and kept them running longer than they could resist. Sometimes quantity has a quality all its own, and in this war, quantity proved decisive. The lessons learned from the Sherman program extended far beyond tank warfare and influenced American military thinking for generations. American industrial capacity, properly mobilized and directed toward war production, had proven that democratic societies could outproduce totalitarian regimes when properly motivated and organized. The Sherman tank program became a model for American military-industrial cooperation, influencing everything from aircraft production to naval construction to the development of nuclear weapons. Soviet observers, despite receiving thousands of American tanks through Lend-Lease programs, drew their own strategic conclusions about American capabilities that would influence Cold War planning for decades. Marshal Georgy Zhukov, architect of the Soviet victory at Berlin and one of the war's most successful commanders, privately warned Stalin about the implications of American industrial power. The Americans have demonstrated that they can produce any type of military equipment in any quantity they choose to produce. This is not a capability we should challenge in peacetime, because it represents a form of warfare that we cannot match. This assessment would prove remarkably prophetic during the Cold War arms race, when American industrial capacity would again prove decisive in producing everything from jet aircraft to nuclear submarines to intercontinental ballistic missiles. The Sherman program had established principles of American military production that would influence defense policy through the present day. Perhaps most importantly, the Sherman program demonstrated the decisive power of industrial standardization and mass production techniques when applied to modern warfare. While German factories were producing dozens of different tank models, each requiring unique parts, specialized training, and individual manufacturing techniques, American production focused on a single adaptable design that could be manufactured anywhere and maintained everywhere using standardized procedures and interchangeable components. This philosophical approach to military equipment would influence American military procurement for the next 8 decades, emphasizing reliability, maintainability, and large-scale producibility over theoretical maximum performance. The F-16 fighter, the M1 Abrams tank, and countless other successful American weapon systems reflect lessons learned from Sherman tank production during World War II. The psychological impact of the Sherman program on both American and German military thinking endured long after the war's conclusion. German tank veterans, interviewed decades later by military historians, consistently emphasized not the technical superiority of their own equipment, but the overwhelming material disadvantage they had faced throughout the conflict. The memory of endless American tank columns became a defining experience for an entire generation of German military officers. American veterans, conversely, developed unshakable confidence in their nation's industrial system and its ability to support military operations anywhere in the world. This confidence would shape American foreign policy throughout the Cold War and beyond, creating expectations of material superiority that would influence everything from the Korean War to Vietnam to modern Middle Eastern operations. The Sherman's reputation underwent significant rehabilitation in post-war military analysis. Historians and analysts, initially critical of American tank design choices and convinced that technical inferiority had cost unnecessary American lives, began recognizing the strategic brilliance of prioritizing production capability over individual vehicle performance. The Sherman may not have been the best tank of World War II in technical terms, but it was arguably the most important. The vehicle that proved industrial capacity could overcome technological disadvantage when properly applied at sufficient scale. Modern military analysts studying the Sherman program identify lessons that remain directly relevant to contemporary defense planning. The importance of logistical sustainability over peak performance, the strategic value of mechanical reliability and maintainability, and the decisive advantage of mass production capabilities all derive directly from Sherman tank experience and continue to influence American military doctrine today. The story of 49,000 Sherman tanks crushing Wehrmacht resistance in 11 months represents more than military history or industrial achievement. It demonstrates how democratic societies, when existentially threatened, can mobilize industrial resources on a scale that authoritarian regimes cannot match, despite their apparent advantages in central planning and resource allocation. The confident laughter of German tank commanders in Berlin conference rooms during 1943 became the stunned silence of defeat by 1945, not through superior technology or individual heroics, but through superior commitment to victory achieved through industrial might applied at unprecedented scale. This incredible story of industrial triumph over military tradition shows us how quickly perceptions can change when faced with overwhelming evidence. The German soldiers who witnessed America's steel tsunami rolling across European battlefields never forgot what they saw during those final months of war, and many would later write in their memoirs about the moment they realized the true scale of American industrial might and what it meant for the future of warfare itself. But this is just one of countless untold stories from this pivotal period in history. What other shocking revelations await us in the archives of World War II? What other moments of disbelief and amazement shaped the course of history and continue to influence our world today? If you found this story as fascinating as I did, I'd love to hear your thoughts in the comments below. What surprised you most about the Sherman tank's mass production success and its impact on German military thinking? Have you heard similar stories from your own family members who lived through this era, either as soldiers or factory workers contributing to the war effort? Your insights and family stories help bring these historical moments to life for all of us. And if you're hungry for more incredible stories like this one, make sure to subscribe and hit that notification bell. We're uncovering these hidden gems of history every single day. And trust me, you won't want to miss what we've discovered for tomorrow's episode. The story of how American shipbuilders turned housewives into welders and built victory one Liberty ship at a time will absolutely blow your mind. Until next time, keep questioning what you think you know about history, because the truth is often far more incredible than fiction.